Hi students, in assignment LU6 A1, I have asked you two problems to solve which are based on the material that is covered in chapter 2. But for some of you, chapter 2 may be difficult to understand. That's why I wanted to show you some example problems in this video which will help you to complete your assignment for this week. I have explained two problems here. So let's focus on the first example problem. Suppose that we are testing null hypothesis mu equals to mu sub 0 versus alternative hypothesis mu is not equal to mu sub 0. Calculate the p-value for the following observed value of the test statistic. Now mu means mean, right? And the test statistic that is given is g sub 0, which is equal to, which observed value of g sub 0 is equal to minus 0.10. So first thing, whenever you see whenever you see that there is a mention of g, you know what type of distribution this is, right? This is nothing but standard normal distribution. So now we have the value minus 0.10 of this particular test statistic, which is standard normal distribution. Second thing we should do is let's open page 47 of your textbook. On page 47 we have table 2.3 which I have opened here. This table is very important. Most of the formulas are given in this table. So let's see the test hypothesis here. Mu equals to 0 and mu is not equal to mu 0, right? And we have been asked to calculate the p-value. So what is in this particular first case here, what is p-value? P-value is equal to 2 multiplied by 1 minus 5 of absolute value of g sub 0, right? So I copied that formula here. Next we know p equals to 2 multiplied by 1 minus 5 of 0.10, which is absolute value of minus 0.10, right? Now phi of 0.10, what is phi of 0.10? This value you can find in the tables, the standard normal distribution tables that are given in the appendix of the book. So the first table in the appendix, which is on page 612, cumulative standard normal distribution. Since I cannot show you the book table here, I have opened similar tables on internet. You can see here 0.10 is your g value, right? So 0.1 here, this second row, and 0.10, right? This first column. If it would have been 0.11, then second row 0.1 and 0.01, second column, right? But since it is 0.10, this is value of phi of z. So that value you can see here. 530. What is that value here is 0.5398. 0.5398. So 2 multiplied by 1 minus 0.5398. Thus p is equal to 0.9204. So similarly, you can solve the first problem in the given assignment, right? Now let's focus on the second example here. The viscosity of a liquid detergent is supposed to average 800 centistokes at 25 degrees centigrade. So mu is 800, right? A random sample of 16 batches of detergent is collected and the average viscosity is 812. Suppose we know that the standard deviation of viscosity is sigma equals to 25 centistokes. So we know mu, we know sigma, we also know n, which is the number of batches, 16, right? So first question, state the hypothesis that should be tested. Now it is very clear that the viscosity of liquid detergent is supposed to average 800 centistokes, right? So the null hypothesis is mean is equal to 800, and the alternative hypothesis is mean is not equal to 800, right? So the hypothesis that should be tested in this particular example is mu equal to 800 and mu is not equal to 800. Now the next question, test this hypothesis using alpha equals to 0.05. What is alpha here? Alpha is significance level, which is 0.05, right? So again we go back to table 2.3. In this case we test of means, that is correct. Our hypothesis is based on means. Variance is known. Variance is 25 centistokes, right? Standard deviation is 25 centistokes. Variance is a square of standard deviation, so variance is known. And first hypothesis, correct? So the test statistics we need to calculate first, which is given by this formula here. G sub 0 is equal to y bar minus mu sub 0 divided by sigma by root n, right? So here I copied that formula here, which is G sub 0. You can see here the same formula. Y sub bar, which is the sample average, right? Random sample of 16 batches and average was 812. So 812 minus 2 mean, which is 800, sigma standard deviation 25, and sample size is 16, right? You get 1.92. Now that is G sub 0. Next, see the condition here, the rejection fixed significance level, criteria for rejection. In the very first case, the criteria for rejection is absolute value of G sub 0 should be greater than G sub alpha by 2, right? So we already calculated G sub 0. Now we need to know G sub alpha by 2, and also then we will see that whether absolute value of G sub 0 is greater than G sub alpha by 2 or not, right? Again we use the table. 2 is equal to 0.025. If alpha by 2 is equal to 0.025, that means phi sub z is 1 minus 0.025. 1 minus 0.025 is 0.975. So we will go back to the table and we will find the value of z at 0.975 value of phi of z. So I'm going back to table. Now we need to look at these values here and find out 0.975. So here the value 0.9750, which is phi sub z, and this value, if you see the first column here, which has value of z 1.9, and then you need to look at the row here 0.06, 1.96, right? So z at G sub alpha by 2 is equal to 1.96. Now you can see that G sub alpha by 2 value, which is 1.96, is greater than G sub 0, 1.92. And what our table says, if G sub 0 value is greater than G sub alpha by 2, then we should reject. This is the rejection area. But since this value, in our case, this value is greater than G sub 0 value, the conclusion is do not reject. the null hypothesis, right? Now let's move on to the next item here. What is the p-value for the test? Again, we go back to the table. P-value is same formula that we used in the first example, right? So P equal to 2 multiplied by 1 minus phi sub g0. We have already calculated a g sub 0 value here, 1.92. We can use that value and we get P value as 0.0549. Next, find a 95% confidence interval on the Now we need to calculate the 95% confidence interval. So how to calculate that? If we go back to the book, on page 46 of the book, at the bottom of that page we have equation 2.36, which says the 100 multiplied by 1 minus alpha percent confidence interval on the true population mean is that is given by equation 2.36. So I copied that equation as it is here, and we have all the values. We have values of all these parameters. We have sample mean, which is 812. G sub alpha by 2 we have already calculated. We know sigma, we know n. So I'm putting all these values here, right? And as you solve this equation further, you will see that the confidence interval, 95% confidence interval for the mean is 799.75. The lower limit is 799.75 and the higher limit is 824.25. Right? So 95% of the time the value of mu should lie between these two limits, and that is it. Now if you have understood these two examples, there should be no problem for you to solve the homework problems. If you have any questions, please let me know. You can send me email or you can see me in my office during my office hours. So good luck on your homework. Thanks. Bye.